Welcome back. You ever run a query on your data lake and feel like you could go grab a coffee, come back, and it would still be churning away? Yeah, you've probably hit a super common, super frustrating wall. It's called the small file problem, and today we are absolutely going to tame it. Okay, so to really get what's going on under the hood when your query's slow to a crawl, let's start with a really powerful metaphor. Picture this. On the left, you've got this chaotic mountain of thousands of little paper receipts. Now, imagine your boss asks you to find every single purchase made on a Tuesday. You'd have to pick up, read, and put down every single receipt. It would take forever. That's your data lake when it's fragmented into tiny files. Now look at the right. Nice, neat, organized binders. To answer the same question, you just grab the binder labeled Tuesday. The difference in effort? It's just massive.
And that simple picture illustrates the core technical problem perfectly. Every time your query engine needs to look at a file, there's a cost. It has to find the file, open it, read the metadata, get the data, and then close it. Now, when you have to do that for thousands or even millions of tiny files instead of just a few big ones, you get what we call massive I/O overhead. Your engine is spending way more time just managing the files than it is actually reading the data. And that is what just kills your performance.
So the big question is, how do we end up with that chaotic pile of receipts to begin with? Well, let's play detective. Because this problem is usually created by a choice that seems smart at first, but has a major flaw. For a long time, the go-to way to organize a data lake was with something called Hive-style partitioning. And the idea is pretty clever, right? You organize your data into actual folders based on a column's value. So you might have a folder for each day's data, for example. This lets the query engine skip reading any folders it knows it doesn't need. But, and this is a huge but, there's a catch. This method works great for columns that have just a few different values, like region or month. But it has a fatal flaw, a kind of kryptonite, when you try to use it on columns that have tons of unique values. And we call that high cardinality. And this is the real trap, because it seems so intuitive. You're probably thinking, well, I query by user ID all the time, so I should partition by user ID. But think about it. If you have millions of users, you're literally telling the system to create millions of folders. And a lot of those folders are going to have just one or two tiny files inside. And boom, there it is. That's the culprit. Partitioning on a high cardinality column is the absolute fastest way to create that pile of receipts we talked about. You've accidentally designed the exact problem you were trying to fix, and it leads you right back to those painfully slow queries. But hey, don't worry, this is totally fixable. So let's talk about the first command you need to know to become the data hero who makes everything fast again. It's all about consolidation. The solution is a command called optimize, and its job is wonderfully simple. It marches through your data, finds all those tiny little files, and intelligently smooshes them together into a smaller number of big, efficient files. It's the magic wand that turns your pile of receipts into those neat, organized binders. The best part is just how simple it is. Look at that. With just one line of code, you can kick off the super powerful compaction process. If you run this regularly, you stop the small file problem before it can ever get out of hand again. Okay, so Optimize takes care of all the active data files. Awesome, but that's only half the battle. Think of it like this. You've organized your closet, but now you have a pile of old stuff on the floor you need to get rid of. Your data lake also accumulates old file versions that need to be cleaned up to keep storage costs down. And this is where the vacuum command comes into play. You see, because Delta Lake supports time travel, it doesn't just delete old data right away when you make updates. Vacuum is basically the housekeeping service that comes in and physically removes the old files that aren't being used by the main table anymore and are past your time travel window. And here's what that command looks like. You can tell it exactly how long to keep the old files around, in this case, 168 hours, which is 7 days. This is basically you telling the system, hey, delete any old junk that hasn't been relevant for the past week. It's a great way to balance having that time travel safety net with keeping your storage bill in check. And what's really great is that there's a safety net built right in. By default, the system will not let you vacuum files that are less than 7 days old. This stops you from accidentally shooting yourself in the foot by deleting data that might still be in use or that you might need to recover. So let's put it all together into a simple, really powerful game plan. Step 1, get your data into Delta Lake. Step 2, for any new tables, definitely look into modern stuff like liquid clustering instead of old-school partitioning. It avoids all these problems automatically. Step 3, make it a habit to run Optimize regularly. Keep those files big and your queries fast. And finally, Step 4,
Run vacuum on a schedule, maybe once a week, to keep your storage nice and clean.
So there you have it. By following these steps, you've just solved one of the single biggest performance killers in the data lake world. You've totally engineered for speed at the storage layer. But that leaves us with one final, pretty important question to chew on. Now that your storage is blazing fast, what's the next bottleneck that's hiding in your data pipeline? Thanks for joining, and keep optimizing.